Well, addition has a friend, and it's subtraction. And subtraction is the reverse of addition. When I had a group of things and I brought them together, we call that addition. If I have a group of things and I break apart a piece of it and move it away, we call that subtraction. In fact, we have that word that we talk about subtractions as being takeaways, right? This take away that is part of how we talk about subtractions. I'm taking away is a language we use in subtraction. So here I had 1, 2, 3, 4, 5, 6, 7, 8, and I had 9 things. I circled 3 of them to take away, and that left me with 6. Notice how this is related to the addition. If I look at these two parts, 6 plus 3 is 9. And if I think about bringing things together and taking them apart as being inverse, I'm going to use the word inverse, operations, I'm operating on things by putting them together and taking them apart. Then in subtraction is the inverse operation of addition, and addition is the inverse operation of subtraction. These things are related, and we will find that we can make any subtraction into an addition. So a lot of mathematicians say there's only addition, but that means on PEMDAS, addition and subtraction are equal value. And you'll find out multiplication and division are of equal value, exponents and their roots are of equal value, and then we have all those grouping symbols up top as parentheses. Some people say PEMDAS, I tend to say PERMDAS. I've known some people that say GERMDAS because they don't like parentheses, they like all grouping symbols. But there's a hierarchy to this, and in that hierarchy addition and subtraction are equal. And in that hierarchy multiplication and division are equal. Right now we're looking at addition and subtraction. Well, I did say that we could look at addition as a number line. So let's look at subtraction as a number line. So if I start at 9, well, in addition I move to the right. So in subtraction, I'm going to move in the opposite direction. Notice how I'm emphasizing these things are the opposites of each other. They're in the inverse of each other. So 9 take away 3, we're going back 1, 2, 3. And we'll find that's the 1, 2, 3, 4, 5, 6th spot. Right? 9 take away 3 gets me back to 6. All of these ways are valid ways of envisioning or mentally thinking about what addition and subtraction are. The quantity underneath it doesn't care how we envision it. It's a quantity. It's a pattern in nature. But we've got to use these tools to help us name these things and move them about. Now, subtraction has an algorithm also. Now, subtraction, order that we write things matter. As I told you with the properties of real numbers, addition has an identity. A plus 0 was A. It commutates. So A plus B is equal to B plus A. Doesn't matter the order we add. Notice I'm really focusing the word add here. And it's associative. And I talked about these yesterday, and I said it's the thing I'm going to keep referring back to. And I have a chart for it up in the yesterday's lectures. There's a little chart of the properties. I would print that out or write it down in a notebook. I will talk about it, any of those properties, at least 3 times per lecture. They will keep coming back up. So if you can glance at those and start getting a feel for them, they'll be very helpful for you to help sort these out, because when we get into the algebraic portion of it, these become very immensely helpful tools. But notice I'm saying addition. Subtractions don't work that way. 9 minus 3 is 6. But 3 minus 9 is not. That's an is not equal to 6. I can't reverse the order of a subtraction. We generally think before we have negative numbers coming in, we have to take away from the big thing. So the algorithm that we have for subtraction requires that we recognize the top and the bottom separately. So if I have 32,481 and I'm subtracting from it 2,112, I want to write this vertical with the left part of the subtraction on top. That will be the top. I will write this part on the bottom. So my algorithm can work. And now I can subtract in columns because place value is doing the work for me. And so I have to look at this, and I have a couple decisions to make. Well, 2 take away 1. That can't happen, right? It'd be really nice if this were greater than 2. And so I look at this number and I say, if the top isn't greater than it, I want to have to borrow one of the 10s. And so I'll put a 1 here because I borrowed it, and that becomes a 7. Now notice what I have here. I have a 7 in the tens place, that's 70, and I have an 11 in the ones place. Well, 11 and 70 is 81. So I'm using my notation to move things around. Well, 11 minus 2 is 9. And then this is no longer an 8 because I had to borrow that 1. It's a 7. 7 minus 1 is 6. 4 minus 1 is 3. Anything minus itself is 0. And 3 minus 0 is 3. And so I'm able to use this algorithm for subtraction. And so place value gives us the ability to do algorithms for additions and subtraction. They let us use the place value to help do the quantity. All right, so that's what the book has for section 2